Imagine building a digital castle where every wall, gate, and hallway matters, because one weak spot can let attackers stroll right in. Infrastructure considerations are the decisions organizations make about how systems, networks, and devices are designed and connected so security is built in from the ground up instead of added later as a patch. Infrastructure considerations focus on how an organization secures its overall environment, including device placement, security zones, attack surface, connectivity, failure modes, device attributes, port security, and firewall types. Each of these choices directly affects how easy or hard it is for attackers to break in and how much damage they can cause. Device placement refers to where security and network devices are physically and logically located. Proper placement helps reduce the attack surface, improves performance by minimizing latency, and increases security by controlling physical access to critical devices. Security zones, also called network segmentation, divide a network into separate areas based on trust levels. By isolating sensitive systems from less trusted areas, security zones limit lateral movement and reduce the impact if one zone is compromised. The attack surface represents all possible entry points attackers could use to access a system. This includes devices, software, user endpoints, data, and even physical infrastructure, and the goal is to reduce and protect these entry points as much as possible. Connectivity describes how systems and devices are linked and communicate with each other. While connectivity enables functionality, too many or unsecured connections increase the attack surface and allow attackers to move more easily through a network. Failure modes describe how systems behave when something goes wrong. Fail open allows traffic to continue during a failure to maintain availability, while fail closed blocks traffic to prioritize security, and the choice depends on whether availability or protection is more critical. Device attributes describe how devices function within the network. Active devices process and manipulate data, making them powerful but more vulnerable, while passive devices simply pass data along and generally have a smaller attack surface. Inline devices sit directly in the data path and actively inspect and control traffic in real time. They provide strong protection but can impact performance and become a single point of failure if not designed carefully. Tap or monitor devices copy traffic for analysis without affecting the data flow. They offer high availability and zero performance impact but cannot block attacks in real time. Port security controls which devices are allowed to connect through specific network ports. It acts like locking individual doors in the network so only approved devices can enter. IEEE 802.1x is a port-based network access control standard that requires authentication before a device can access the network. It works with authentication frameworks like EAP to verify users and devices. Extensible Authentication Protocol, or EAP, is a framework that supports multiple authentication methods. It allows secure and flexible authentication for wired and wireless networks. Firewalls are security devices that filter traffic based on rules such as IP addresses, ports, and applications. They are typically placed at network boundaries to control what enters and leaves the network. A web application firewall, or WAF, protects web applications by inspecting HTTP traffic and blocking common web-based attacks. It focuses specifically on application layer threats. Next-generation firewalls, or NGFWs, combine traditional firewall features with advanced capabilities like deep packet inspection, intrusion prevention, and application awareness. Unified Threat Management, or UTM, combines multiple security tools into a single device. This approach simplifies management while providing stronger protection than using individual tools alone. Layer 4 firewalls operate at the transport layer and filter traffic based on ports and protocols. Layer 7 firewalls inspect application-level content to detect more advanced and hidden threats. The key takeaway is that strong infrastructure design reduces risk by controlling access, limiting damage, and monitoring traffic effectively, and if this helped, consider liking and subscribing for more lessons like this.